Okay, so example 4 says, what is the inverse of f of x equals 2x plus 5? And it says, verify the functions are inverse using function composition. So we did function composition last chapter, just a refresher on that. If I have, let's say, f of x equals 7x plus 2, and let's say g of x equals 3x minus 1, and I want to do f of g of x, right? F of g of x just means I'm going to do f of, I'm going to change g of x into 3x minus 1. So just do a substitution. I'm just making up stuff here, all right? Inventing things off the top of my head. I'm just refreshing memory how to do function composition. So f of g of x means f of whatever g of x is, in this case 3x minus 1. And then f of 3x minus 1 says go up to function f and change all the x's to 3x minus 1. So function f says 7 times x plus 2. 3x minus 1 goes in there. 7 times 3x is 21x. 7 times 1 is minus 7 plus 2. 21x minus 5. And what we did last chapter, we did that a few times in class, and then you had some homework assignment involving that, right? So function composition. So what they're asking us to do is we have a function given to us. They want us to create the inverse function. So that'll be our second function. And then we want to do function composition to verify the functions are inverses, and I'll tell you exactly what the answer should look like when that happens. So let's start off with making the inverse function. If I'm starting off with f of x equals 2x plus 5, I'm going to call it y equals 2x plus 5. To make the inverse function, I'm going to swap x with y and y with x. Everything else stays as is. So this y becomes an x, 2 stays 2, this x becomes a y, plus 5 stays plus 5. X becomes y becomes x, everything else stays as is. To complete the inverse function technique, I need to solve this for y. Right now it's 2y plus 5 equals x, so I've got to move the 5 over here. X minus 5 equals 2y, divide both sides by 2, y equals x minus 5 over 2. If I look at my original function, x could be all real numbers, so you can double anything and add 5 to anything. You get one answer goes in, one answer comes out every single time. Same thing down here, x can be anything. I can subtract 5 and divide anything by 2. And when I subtract something by 5 and divide by 2, I get one answer every single time, right? I don't get multiple answers. So one input leads to one output for every value of x. So that means my f inverse of x is going to be x minus 5 over 2. So our original function is this. Our answer, our inverse function is this. That's part A. What is the inverse of that? The inverse of that is x minus 5 over 2. The verification part, if you verify functions are inverse, this is what should happen. If I do f of f inverse of x should equal f inverse of f of x should equal x. If I compose f with f inverse, I get x out. If I compose f inverse with f, I get x out. So if I do what I did on the last page a moment ago with these two functions, the original and the answer, and I do f of f inverse, and I do f inverse of f, both answers should come out as x. If it is, I'm right. If it isn't, I messed up. So here's what it looks like. If I look at f of f inverse of x, a little different colors here. The board is lagging. There we go. Let's make that red. All right. F inverse of x is this function, right? So when it says f of f inverse, it really means f of this thing, x minus 5 over 2. Just our regular how to do a composition of functions that we did last chapter. f of a function, change the function to what the function is. Then f of something means to take function f, which is this function up here, and change the x's into this thing right here. So f of x minus 5 over 2 is 2 times x minus 5 over 2 plus 5. And I simply went up to function f up here, change the x into x minus 5 over 2, because that's what x is supposed to be changed into. If I multiply 2 times this fraction, this 2 cancels that 2, leaving us with the top, which is x minus 5. And x minus 5 plus 5 equals x. If you do a function composition with a function and its inverse, you should get x as the answer. So we verified that that order works. F of f inverse became x. You might recall from the last chapter also that function composition is not commutative. So just because that equals x doesn't mean the other direction equals x. We have to check the other direction. So I'm going to do f inverse of f of x. All right, so just like I did over there, f inverse of f of x is that thing, right? F of x is there, and f of x is this function up here. So this means f inverse of 2x plus 5. Again, just like we did function compositions last chapter, change f of x to what f of x is. F inverse of 2x plus 5 means to come over here to function f inverse, which is this guy here, change the x into 2x plus 5. So it looks like this. 2x plus 5 minus 5 over 2. This is x, this is the new x, minus 5 over 2. On top, what is 2x plus 5 minus 5 simplified to? 2x. So we get 2x on top divided by 2. What's 2x divided by 2? X. All this stuff here is the verification process. Here's my answer. Here's where I composed f to f inverse. I got x. Here's where I composed f inverse to f. I got x. Both of them came out to x, which means that that is true, which means that this is actually the inverse function. So we're right. So get the inverse function, perform the composition, see you get x on both, that verifies you're right. That's what you're looking to do. This and this. The verification is how you do it. So everything you do here, not just the x and the x, but that you did a composition to get to those x's. So the verification is all this stuff here, and the answer is just the green stuff there.